The first question is find the cube root of 12 using Newton-Raphson method. Correct up to 4 places of decimal algorithm. So the solution is first x cube is equal to 12. Now the equation fx is equal to x cube minus 12. इसको अपन ने इक्वेशन नंबर फर्स्ट माना. फिर put x is equal to 2 in equation number first. So we get minus 4. Now put x is equal to 3 in equation number first. So we get 15. So we got one negative value and one positive value. So the roots lies between 2 and 3. And x0 is equal to 2. Now using the Newton-Raphson method. So the formula is xi plus 1 is equal to xi minus fxi upon f plus xi. So is equal to xi minus xi cube minus 12 upon 3xi square. So xi plus 1 is equal to 1 by 3 bracket 2xi plus 12 over xi. इसको अपन ने मानना क्वेश्चन नंबर सेकंड. नाउ हम पुट करेंगे इसमें वैल्यू. सो पुट i is equal to 0. इसमें अपन ने i is equal to 0 माना है. So x1 is equal to 1 upon 3 2x0 plus 12 upon x0 square. So we get x1 is equal to 2.33. Now if you put I is equal to 1, then we get x2 is equal to क्या 2.2902. Put I is equal to 2. Now put I is equal to 2. So x3 is equal to 1 by 3 2x2 plus 12 upon x2 square. So we get x3 is equal to 2.2894. Now put I is equal to 3. Similarly, if you put I is equal to 3, then we get x4 is equal to 2.2894. So cube root of 12 using Newton-Raphson formula is 2.2894. So this is our answer. Now the second question of our internal first set A. Write an algorithm flowchart in Python program for finding square root of 12 using a fixed point iteration method. Now the step 1 is start. Step 2 define function fx. Step 3 define derivatives of function as gx such that gx is less than 1. Now the step 4 input. So we take input. Initial guess is x0, tolerable error e, and the max iteration n. Step 5 initialize iteration counter. So I is equal to 0. Then step 6 calculate. So x1 is equal to g of x0. Step 7 increment I is equal to I plus 1. Now the step 8 if I is greater than n. Then print not convergent and go to next. So the step 9 set x0 is equal to x1 for the next iteration. Now the step 10 if fx is greater than e, then go to step number 6, else go to next. Now step number 11 display x1 as a root. Step number 12 stop. So this is the algorithm. Flowchart for finding the square root of 12 using fixed point iteration method. So we come to the next question of set A. So give the output of the Gauss-Jordan algorithm. Now we have to find the output by using Gauss-Jordan algorithm. So this is our matrix. Now first we have to solve it. R2 is equal to 5R2 plus 3R1. R3 is equal to 10R3 minus 3R1. R2 is equal to 2R4 minus R1. So we get this matrix. Now again, R1 is equal to 16R1 plus 7R2, R3 is equal to 16R3 minus 31R2, R4 is equal to 16R4 plus 11R2. Now we get this matrix. So then we get this matrix. Now again, we have to make R1 is equal to 372R1 minus 76R3. Now R2 is equal to 93 R2 minus R3. R4 is equal to 372 R4 plus 68 R3. So we get this matrix. Now R1 is equal to R1 by 2, R2 by 2, R4 by 2. So we get this matrix. Now again we solve this and we get this matrix. Then R4 divided by 2. R4 is equal to R4 upon 2. Now we get this matrix. R4 again R4 divided by 2. Then we get this matrix. R4 again divided by 2. Then we get this matrix. Then again we solve it. R1 is equal to 1739 R1, R4 to 7640. Then we get this matrix. So we get lower triangle and upper triangle